In this video, we are going to discuss about the common emitter amplifier circuit. On the completion of this topic, students will be able to interrupt the various applications of diode, and also they can able to classify the various configuration and biasing techniques of BJT, and they can know about the applications of the each components. In common emitter amplifier circuit, we will be grounding the emitter terminal. So here we are considering the BJT. In that BJT, we have used the voltage divider bias circuit. So here the biasing circuits contains the resistors as R1, R2. Since we are considered here the voltage divider circuit, so here the resistors we are considered as R1, R2 and RE. So this totally forms the voltage divider biasing circuit for this common emitter amplifier, and also this seeks the operational point of the common emitter amplifier. And here we are considering the input capacitor which is present at the input terminal, that is C1. So C1 which is used for coupling the signal to the base of the transistor, which we are keeping as an input, and it blocks any other DC component which is present in this signal, and also it only passes the alternate signal for amplification, and blocks the direct current component. Only amplified, that is alternate signals is only allowed to pass through it for amplification. So this is the use of the capacitor, that is C1. And next one is the emitter bypass capacitor CE. So here we are using one bypass capacitor. So in this common emitter amplifier, we will be using two types of capacitors. One is we will be bypassing it, another one we would be unbypassing it. So here we are considering the bypassing capacitor, which is we call it as CE. So CE, which is connected in parallel with the emitter resistance RE, that provides the low reactive part, that is amplified from the alternative current, and also this is connected parallel with the emitter resistance, that is to provide low reactance path to the amplified alternative current. Here we are using this capacitor, that is CE, which is used only for reducing the output voltage, and also this will reduces the gain value. And the next one is the output coupling capacitor C2, that is output coupling capacitor C2 is nothing but this couples the output of the amplifier which is present at the load or to the next stage of the amplifier. So it blocks the DC current and passes only the alternate part of the amplified signal here. And why we are going for this capacitor means that is need for the C1, C2 and CE is nothing but that is impedance of the capacitor we are giving us XC is equal to 1 divided by 2 pi into C. So here the phase reversal, that is the phase relationship between the input and the output voltage, we are determining by considering only the positive as well as the negative half cycle separately. So we will be taking either the positive cycle or we will be taking the negative half cycle. So by considering the effect of this both the positive and the negative half cycle separately, we can find out the phase relationship between the input and the output voltages. Then the collector current is, that is beta times the base current. So we are writing this collector current will also increases when there is increase in the voltage drop, that is VC is equal to VCC minus IC into RC. So whenever there is an increase in the IC, then this results in the drop in the collector voltage, that is VC, and then VCC will be set as constant. So if this voltage input voltage increases in the positive direction and output voltage goes in the negative direction, and the negative half cycle of this output voltage we can obtain from the positive half cycle of the input. So in the case of the negative half cycle, if you see, means that is AC and DC voltage will oppose each other, so there will be a reduction in the base current. So due to this collector current and the collector resistance will be decreased, so that both will get reduced, and that output voltage finally it gets increases. So in this case, the positive half cycle at the output for the negative half cycle at the input can be obtained. So if there is, so there will be a phase shift of 190 degree between the input and the output voltage for an common emitter amplifier. Quiz questions on this common emitter amplifier circuit. That is, first one is the base current amplification factor beta is given by, and the next one is which of the following configuration has the lowest output impedance, which of the H parameters corresponds to RE in a common base configuration. Thank you.